Did you know the Earth hides treasures created under unimaginable pressure? Discover how ancient volcanoes and hidden clues in nature can lead you to real diamonds. And yes, you can find them yourself. Ready to uncover nature's most precious secret. Hidden beneath layers of earth or glistening among riverbed stones, diamonds in their raw form are far closer than most imagine. In regions shaped by ancient geological activity, like eroded riverbanks or volcanic landscapes, these pure carbon gems have been carried across vast distances by natural forces for millennia. Volcanic eruptions, rivers wind, and time distribute diamonds into areas that might now appear barren. South Africa, Brazil, and parts of Asia hold such concealed treasures in alluvial deposits, remnants of ancient waterways waiting silently beneath dry riverbeds or amidst gravel layers. Understanding your surroundings is essential. Geological observation unveils signs like volcanic rock formations, kimberlite or lamproite, that often contain diamonds alongside minerals like garnet and spinel. By unlocking the secrets of geology, the thrill of discovery transforms common ground into pathways of possibility. This appreciation of the Earth's processes sets the stage for exploring how diamonds are formed and transported. Diamonds are born deep beneath the Earth's surface, where conditions are anything but ordinary. At depths of around 150 kilometers, the mantle generates extreme pressures and temperatures surpassing 1,000 degrees Celsius. These forces combine to transform pure carbon into one of the hardest substances on Earth, diamonds. Unlike other gemstones, diamonds bear the marks of a process shaped not over years but over billions of years, a testament to nature's power and patience. Volcanic eruptions serve as the catalyst in their story, lifting diamonds from their birthplace to the Earth's surface. These eruptions, classified as kimberlitic or lamproitic, are rare, violent events. They channel diamonds trapped in volcanic rock formations called kimberlite pipes upward at astonishing speeds. Without such eruptions, diamonds would remain hidden, locked deep within the Earth, unreachable by human hands. But the journey of a diamond doesn't end at the surface. Over millions of years, nature continues to reshape and redistribute these gemstones. Rivers flowing over eroded volcanic rocks carry diamonds far from their source, depositing them in alluvial plains, ancient riverbeds, and coastal gravel deposits. Regions like southern Africa, Brazil, and parts of India illustrate this process vividly. There, diamonds have been discovered hundreds of kilometers from their original volcanic origins, carried by the relentless force of water and erosion. Consider South Africa as an example. Intense volcanic activity millions of years ago deposited diamonds within deep kimberlite formations. As erosion chipped away at these landforms, rivers distributed diamonds across vast distances. This process created alluvial deposits areas that have become hotspots for mining and discovery. Similarly, the Amazon basin in Brazil reveals how diamonds displaced from their volcanic sources can settle in unexpected nutrient-rich soils waiting to be uncovered. Wind and weather also contribute to the diamond's movement. Over time, sediments containing diamonds gather in low-lying areas where heavier materials accumulate. These natural collection points remain critical for diamond prospecting today. What's remarkable is how nature uses its own forces, water, wind, and gravity, to scatter these gems across diverse environments, creating opportunities for discovery in the most unlikely locations. Understanding these geological processes lays the groundwork for finding diamonds in nature. Recognizing how diamonds travel through river systems, how volcanic activity ties into their formation, and where erosion deposits them are all critical for tracking down these elusive treasures. This knowledge also bridges us to the essential tools for identifying where diamonds might hide. Knowing the role volcanic rocks like kimberlites play is vital, leading us into the next step, uncovering key geological indicators for diamond searching. Kimberlite and lamproite are the geological treasures you'll want to focus on when searching for diamonds. These volcanic rocks act as primary carriers, transporting diamonds from their birthplace deep in the Earth's mantle to the crust. Recognizing these rocks is your first step. Kimberlite, for example, often reveals itself through distinctive greenish or bluish tones. These colors, though subtle, can be spotted with practice, especially in terrains associated with ancient volcanic activity. More significant than the rocks themselves are the minerals they often bring along. Garnets, ilmenite, spinel, and chromite are pivotal indicators, forming what prospectors call a mineral signature. Finding these minerals doesn't just hint at diamonds, it increases your chances of success exponentially. For instance, garnets linked to kimberlite deposits have a vibrant red hue and are sought after by seasoned diamond hunters. Learning to identify these companion minerals is key to uncovering diamond-bearing zones. Equally vital is understanding where these rocks and minerals might have traveled. Volcanic eruptions that happened millions of years ago scattered diamond-rich materials across various landscapes. Over time, natural processes like erosion and waterways redistributed these resources. Regions with historical volcanic activity, such as parts of Africa, Brazil, and India, hold rich deposits, though identifying precise areas often requires studying geological maps. Mistaking diamonds for other minerals is a common challenge among beginners. Diamonds in their natural state don't shine like the faceted gems displayed in jewelry stores. Instead, they often appear as dull, translucent crystals with rough edges shapes that are frequently octahedral or cubic. Novices might confuse them with quartz or glass fragments. However, the density and structure of a diamond observed closely with tools like a loupe are defining features that set it apart. Physical exploration also plays a significant role in locating promising sites. Riverbeds, whether active or ancient, are valuable zones for exploration. Diamonds, due to their unique combination of hardness and relatively low density, can travel far from their source. Gravel beds, especially those in curved sections of former waterways, act as natural traps where diamonds and heavier minerals accumulate over time. Carefully excavating and sifting through these layers offers insight into potential finds. Understanding these indicators doesn't just make searching easier. It lays the foundation for effective methods like sieving and panning used in practical diamond prospecting. Recognizing a promising geological environment ensures that when you begin your search, whether in riverbeds or volcanic terrains, you're working in areas with the greatest potential for success. This knowledge is invaluable as we explore practical techniques for extracting diamonds in the next segment. While diamonds might seem inaccessible to the average explorer, finding these precious stones in nature is surprisingly achievable with basic techniques and tools. Ancient riverbeds and dry stream paths hold incredible potential for diamond deposits formed and scattered by geological processes over millions of years. Identifying these areas is critical, but the techniques used to extract diamonds from natural environments are just as important, offering opportunities for those willing to put in effort and patience. One of the most effective methods for diamond searching involves sifting through gravel using sieves and buckets adapted for separating materials. Targeting sediment layers that have remained stable for centuries or even millennia is fundamental. Begin by excavating areas such as old riverbanks, the curves of dry streams, or deposits found in lowland locations where heavier minerals naturally accumulate. Focus on regions like alluvial deposits where water once flowed and sorted heavier materials, including diamonds, into concentrated areas. The process itself, known as panning, is simple yet methodical. After gathering gravel in a sieve, running clean water over the mixture is crucial to isolate lighter materials from denser particles that sink to the bottom. Heavy materials such as magnetite, hematite, and if fortunate, diamonds remain in the sieve post-filtration. Success comes with persistence. While diamonds are not guaranteed, this straightforward technique increases the likelihood when applied consistently. Rural miners in diamond-rich regions like Brazil frequently use this method to detect valuable stones in areas of historical erosion. Observational skills also play a key role in identifying potential diamond-rich zones. Recognizing crystal shapes and appearances is essential for distinguishing diamonds from other minerals such as quartz or glass. In their natural state, diamonds appear as opaque or translucent crystals with irregular surfaces often mistaken for other stones. Learning to recognize basic forms like their octahedral or cubic shapes greatly enhances accuracy. Geology enthusiasts should also inspect the clarity and geometry of found crystals, keeping an eye out for signs of diamond-specific traits that reveal their unique origins. Beyond traditional panning and sifting techniques, nature itself provides subtle, yet valuable clues about where diamonds might be hidden. Some experienced prospectors pay attention to how animals interact with the terrain. Birds, rodents, and other creatures disturbing loose soil can indicate areas enriched with minerals underneath. Nature's movements, such as erosion after rain or shifts caused by seismic activity, can also expose treasure previously buried. For example, diamonds have been discovered embedded in tree roots, cracks in rock formations, and even river cascades where sedimentation creates natural traps. A prime example comes from the agrarian communities in northern Brazil, where diamond prospecting melts seamlessly into daily routines. Generations pass down knowledge about identifying potential diamond sources, transforming excavation into a cultural tradition. For these families, taming tools like sieves and buckets becomes both a resource of supplemental income and a shared activity that promotes community bonding. The ability to discern diamonds at a glance without mistaking them for quartz is a skill honed over decades of practice and observation. By combining simple tools with acute observational techniques, even amateur enthusiasts can access the thrill and success of diamond discovering in nature. However, spotting and isolating stones isn't the final step. Proper identification is essential to determine authenticity and value. Understanding this foundation prepares viewers for the upcoming section on testing and identifying potential diamond finds, which provides advanced methods for verifying whether your discovery is the real deal, ensuring each effort brings clarity, reward, and deeper connections to the geological stories of our planet. The true value of any diamond lies in confirming its authenticity. To test and identify diamonds, the most efficient method begins with assessing its hardness. Diamonds are the hardest natural substance on Earth, capable of easily scratching glass or metal surfaces. This fundamental property makes diamonds stand out from other minerals that may only resemble them. When conducting this test, apply steady pressure with the suspected diamond on a smooth glass surface. Scratches indicate potential authenticity. Another distinctive characteristic is how diamonds interact with light. Unlike common crystals, diamonds refract light, uniquely producing internal reflections that bounce in sharp angles. To perform the transparency test, observe the crystal under a direct beam of light. Diamonds emit a remarkable brilliance and dispersion unmatched by quartz or glass imitations. Pay attention to the subtle, vivid sparkle, an indicator that sets diamonds apart. Natural diamonds also reveal distinctive shapes, commonly octahedral or cubic formations. Unlike polished gemstones, raw diamonds may appear unassuming with irregular edges, a rough exterior, and sometimes a slight opacity. These organic features can make identification challenging for beginners, but recognizing these shapes increases certainty. For absolute clarity, employing professional gemological services is highly recommended. Certified gemologists use advanced techniques like spectral analysis and fluorescence tests to confirm authenticity, ensuring whether a stone is an actual diamond or merely an imitation. For enthusiasts, portable identification kits are available, which offer accessible tools for preliminary assessment. These kits equip prospectors and hobbyists with reliable methods to analyze suspicious stones, directly streamlining the identification process. While personal testing delivers initial results, verification from experts strengthens reliability. This critical phase ensures sustainable ethical exploration remains rooted in science. Understanding these methods highlights the importance of precise identification, setting the stage for responsible practices explored further in the next scene. Exploring for diamonds requires more than geological knowledge. It requires responsibility. Adhering to local laws is not just a legal necessity, but a way to protect ecosystems and communities. Many countries regulate the collection of minerals to prevent over-extraction and ensure that fragile environments are preserved. Respect for protected lands and private property is essential to maintain harmony with both nature and local livelihoods. Damaging flora, displacing wildlife, or altering water sources during exploration can disrupt entire ecosystems, sometimes irreparably. Sustainable practices like those found in small cooperative mining efforts across Brazil illustrate a better way forward. In these communities, local miners work together responsibly, sharing resources and distributing benefits while preventing large-scale environmental damage. Ethical diamond seeking is about more than finding treasures. It's about fostering a balanced relationship with the earth, ensuring its resources endure. This mindful approach lays the foundation for the emotional resonance these stones carry. Diamonds forged deep within the Earth's mantle represent unparalleled resilience and transformation. Over billions of years, extreme pressure and heat shaped these crystalline structures, marking them as fragments of Earth's ancient narrative. More than gemstones, they symbolize survival against nature's most intense forces, embodying a story of endurance and beauty. Beyond their geological marvel, diamonds hold profound emotional significance. Their rarity and brilliance have made them universal tokens of commitment, strength, and timeless love. At the intersection of science and sentiment, these stones connect us to the planet's evolution and serve as tangible reminders of the countless secrets hidden beneath our feet. Searching for diamonds in nature becomes more than a quest for wealth. It's an invitation to appreciate the complexity and harmony of Earth's processes. These journeys cultivate patience, respect, and admiration for a world where even the smallest discoveries carry immense meaning. From their formation deep within the Earth to their journey across vast landscapes, diamonds represent more than just geological marvels. They are symbols of resilience and transformation. Identifying the right tools, such as sieves and panning methods, allows anyone to uncover these hidden treasures while respecting nature. Recognizing key geological markers like kimberlite rocks and accompanying minerals dramatically increases the likelihood of success. Equally vital is developing the ability to differentiate raw diamonds from ordinary stones using simple tests for hardness or light refraction. However, none of this is possible without respect for local laws, sustainable practices, and an appreciation for the environment. Diamond searching is not just about wealth, it's about uncovering Earth's history and connecting deeply with the natural world. Whether exploring for knowledge or curiosity, let the experience inspire awe and mindfulness. Embrace the challenge, observe with intention, and above all, tread gently.